Hello students, welcome back to the class. So we have already completed this chapter. Okay, so we are left with some of the topics which is concentration terms. So I will deal with that in the next lecture. Before that, we will do some questions which will be related to your CBSE exam. So it will be kind of a sample thing related to this chapter. So let's start this thing. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using the generative AI, which is experimental. So this is the marking scheme that is being often seen in the 11th class end exam. So this is just a sample question paper. It may vary in your case, but more or less it will be similar to this kind of distribution. So here we will first of all we will have 18 questions which will be MCQ, and each of this will be of 1 mark. Then we will have an MCQ type but a assertion-reason type question. So there are 3 questions related to it and 1 marks is given to each of this. Then moving on to the next one, we have very short answer. One question has a marks of 2 and there are 5 questions in total. Then we have short answer which starts from 26 to and ends at 31. So that concludes total of 6 questions. At last, we have a long answer question in section D, which is 5 marks, and there are 4 questions like that. And the last one is the case study, which starts from 36 and ends at 38. So there will be total 3 questions, each comprising of 4 marks. Now there can be an internal choice. So in section B, there are 2 questions with an internal choice. Then we have this short answer where 3 questions have an internal choice. So Nisag, I haven't removed you. So it may be due to the unstable internet connection. Then we have this long answer type in which 2 questions are having option, means there is a choice of attending it. Yes, you can rejoin. And in the case study also, 1 sub part in each will have a 2 question. Clear? So this is the basic marking scheme which is followed in most of the schools. Although it may, again I'm mentioning it, it may vary depending on the teacher, but more or less it will look like this. Not a issue, Nandini. If you are attending any other, or if you are doing any other say attending any other board, you may get the concept from here at least, and it is possible that the type of question may be same. So you would see a MCQ type in your board, you would see a long answer type and a short answer type. Okay, so what I will try is to say I will try to cover each type of question. So I will not have 18 questions MCQ. I will try to cover 2 to 3 questions from each section, exempting this case study. So I have put questions from the MCQ part, from the assertion, reason, very short, long answer. So this is your first question. In this, you have to determine the empirical formula of sucrose, whose molecular formula is given as C12H22O11. Now, 4 options are there. I am giving you some time to solve it. Just write your correct answer in the chat section. So already there is a vote for answer C. Anyone else? What will be the empirical formula for this given sucrose? I've already taught you about the molecular formula and the empirical formula. So again, one more answer, which is again voting to C. So Sriram is saying C. Okay. So let's see the correct answer. How we will solve this question? For that, you must be clear about the empirical and molecular formula. So the correct answer will be C. Okay. So the correct answer will be C. Let us see how we can do it. Now, for that, you have to look at the molecular formula of this sucrose. Then you will find it very easy to say that your empirical formula is the same that is being given as the molecular formula, which is C12H22O11. So this is the MCQ type question. If you just write the correct answer in your answer sheet without explaining it, you will get the marks. Now, why it is the correct answer? I have to explain it, right? The reason behind is that if you see these three numbers, these are 12, 22 and 11. Now, while writing the empirical formula, we take the simplest whole number ratio. I've already explained this thing. For the case of C6H12O6, which was our glucose, 6 was the multiple which was getting multiplied throughout. But in this case, 12, 22, 11 have no other number in common or no other factor in common other than 1. So you cannot simplify it further. So of course you can get 11 and 22 in the table of 11, but you will not find 12. If you find 12 and 22 in the table of 2, you will not find 11. So for that reason, you can't simplify this ratio further. If you try by yourself, you can see it very clearly. So those who are answering A, did you get the point why I'm saying this as the correct answer? So remember the concept of empirical formula. You have to reduce your stoichiometric coefficient to the smallest whole number ratio. Okay. So is it clear? Should I move to the next question? Okay. Now, our next question. So it is a question from the mole concept. So you can find the concept related to this in the NCERT also in the section 1.8. If you are unaware about this, you can just go and read it and watch my lecture, which is there in the website and the YouTube. So the question is saying that what is the number of moles in 22 grams of CO2? Your options are A 0.5 mole, B 1 mole, C 2 moles and D 4 mole. So I am already getting answers which is supporting option A. So let's see what is the correct answer. So it's very easy to solve. It is being written here that you have to find the number of moles. How do we find the number of moles? We have a very simple formula. If you apply that, you will get the number of moles as 0.5, which is option number A. So again, this is an MCQ. It will comprise of 1 marks. The formula goes like this. It needs, first of all, the molar mass of CO2. The molar mass of CO2 is what? It will be 12 plus 16 into 2 for oxygen, because 16 is the atomic mass and 12 is the atomic mass of carbon, which will give you 44 gram per mole. So this is the molar mass of carbon dioxide. Now next, how do we calculate the number of moles? It is very simple. Given mass which is 22 grams divided by the molar mass which is 44 gram per mole. We have calculated it, right? Now if you calculate this value, it will be 0.5. Again, if you don't solve it whole and write the correct answer only, you will surely get the 1 marks. So the correct answer is 0.5 mole. Yes, very good. So you can apply the unitary method also. So if anyone has any issue, you can ask it here without any hesitation. Okay. Anyone who has any issue in this question? Okay. So let us move to the next one. Our next question is a assertion reason type. So this is also an MCQ type, but here it will be a assertion reason type. Now this type of question is also asked in the JEE, and now it is also seen in the CBSE exams. The question is basically asking you that how you will give a statement and what will be the reason for that statement. So our statement is that if we take 32 gram of sulfur dioxide and 8 grams of methane, then they both will contain the same number of molecules. So first you have to verify that is this statement true. Okay, you have to verify that is this statement true. Nitish, now it is okay. Am I audible now, Nitish? Okay. So what I am saying is that you have to first verify this statement, that is this statement true or not. The second thing you have to see that if this statement is true, then the reason that is given is explaining your point or not. So two things are there. So you have four options, that A and R are true and R is the correct explanation. Second one is A and R are true, but it may be possible that your reason is not explaining the assertion. Third one is A is true but R is false, and fourth one is A is false but R is true. So let's see if this is true or not. Before that, let me make you understand the question. The question is saying that we have 32 grams of SO2 and 8 grams of methane. So will they have same number of molecules? So this is the first question. And second question is saying that if you take suppose 2 moles of any compound, then it will contain, then the both will contain same number of molecules. Means if you take if you take 2 moles of sulfur dioxide and 2 moles of methane, then they both will contain same number of molecule. You have to identify that whether it is true or not. And second thing is that if it is explaining your assertion or not. So I have a mixed opinion from each of you. The correct answer is A. Okay, that both your assertion and reason are true and R is the correct explanation of A. So in this type of question, you have to keep your mind cool first of all, because the statement may be very tricky. So just read it very carefully. How we will solve it? For that, we have to count, or you can say we have to calculate, not count, we have to calculate the number of molecules in each of this. For that, we will need number of moles. Now to calculate the number of moles, we need the molar mass. So molar mass of SO2 can be calculated as 32 plus 2 into 16. So 32 for sulfur and 2 into 16 for oxygen, which will give the molar mass of sulfur dioxide as 64. Now what is the moles of CO2? SO2, it will be given mass by molar mass, which is equals to 0.5 moles. Now is this thing true? Yes, it is very true. So it is having 0.5 mole. Anyone has any issue till this point about the calculation of number of moles? They can ask. Okay. Yes, Nandini, what is your doubt? So I am asking you doubt regarding this step. Okay. If you have a doubt regarding the whole question, let me first complete, then you can ask. Okay. So if you have any doubt in this step, you can ask. Okay, just type your doubt. I am moving forward. So it is simply the formula, which is given mass by molar mass. So we know the given mass, it is 32 gram for sulfur dioxide, and molar mass is being calculated in the first step, which is 64 gram per mole. So we have taken this thing, given mass by molar mass, which is 0.5 mole. 32 by 64 will give you 0.5 mole. Now in the next step, we have methane. Okay, so we have to calculate the number of moles for methane also. So methane will have a molar mass of 16. You can see it's a very easy calculation to do. If you divide the given mass, which is 8 gram, by 16, again you will get 0.5 moles of methane. Now both have the same number of moles. You can see it. Methane and your sulfur dioxide both have the same number of moles. So if they have the same number of mole, they will have the same number of molecules also. How is it true? So if I am saying 1 mole, that means I am having 6.022 into 10 to the power 23 molecules. As simple as that. Now if I am saying 0.5 moles, then I am having 0.5 into 6.022 into 10 to the power 23 molecules. Is it clear? So the reason is also true, because since their number of moles is same, and that is the reason they will have the same number of molecules. So first you will calculate the number of moles, which will give you a clear idea that they both have the same number of mole. Now since they have the same number of moles, they have the same number of molecules, and that same reason is been written here. So we can say that our assertion and reason are both true. Hence the correct answer is A. Again, you will only get marks if you write the correct answer, because it is a MCQ type question. Now in this whole process, anyone has an issue, they can ask in the chat section. Okay. Now moving on to the next question. So this assertion reason type comes under your MCQ type only. You have to explain the thing. So why do we take the Avogadro number? Yeah, it is important to learn the mass of all elements up till the sodium line at least. Okay. So again I am explaining. So first of all, we have calculated the molar mass, and then we have used it to calculate the number of moles, which comes out to be same for sulfur dioxide and methane, which is 0.5 moles. Now what will be the number of molecules in 0.5 moles? So it's very easy. We know that 1 mole of any entity will contain 6.022 into 10 to the power 23 particles. Okay, so we have been doing this since the start of the chapter. Now since we have 0.5 moles of SO2, that means if 1 mole have 6.022, then 0.5 will have 0.5 multiplied by 6.022 into 10 to the power 23. Again, the simple unitary method is being applied here. If you calculate this, you will get your value as 3.011 into 10 to the power 23. Then we have the same number of moles for CH4 also. We have seen the calculation already, that they have the same number of moles, and hence they will have the same number of molecules. So what is being said here is that if they have same number of moles, then they have the same number of molecules. So it is being written that SO2 moles are same. Okay, so you should be clear about it. If I am saying that SO2 moles are same, means the SO2 molecules are same. So those who have doubt in it, is it clear now? or should I explain it once again? So you're free to ask question here. So again I am explaining it. So till this point you have any issue in the calculation of number of moles? So did you get the point of how do we calculate the number of moles? Then I will explain the next part. Okay, Parth. So did you get the point of calculating the number of moles? Am I audible, Parth? Yes. So you are clear about the calculation of number of moles. You are not getting the point that why I am saying that there will be equal number of molecules. So when I say that we have 1 mole, then it is very clear from that we have this much number of particles. So think it of in the way that if one chocolate costs 2 rupees. Okay, so again I am taking this analogy. It's very simple for me also every time I use it. So if one chocolate costs 2 rupees, then what will be the cost of 2 chocolates? It will be rupees 4. Okay, so it's a very simple analogy. Now how are we getting this 4? By multiplying this and this. Right? We are doing this thing in this whole process unknowingly, I would say. But we are doing this thing to get this value of 4. Clear? Is this point clear? And if this is clear, then you would also able to recognize then why I am multiplying this 1.5 by 6.022. So when I am saying that 1 mole has 6.022 into 10 to the power 23 particles, okay, then what will be the count in 0.5? It will be again this multiplied by this. So we are multiplying this thing. Now is it clear, Parth? Okay. So moving on to the next thing. So this is a assertion-reason type question. Moving on to the next type. So here is a very short answer type question. So it is basically from the NCERT section 1.10.2. Okay. So here what you have to do is to see that which is the limiting reagent. Okay, which is the limiting reagent of all. How we'll do it? We have to use the stoichiometric calculation. What we have to use? We have to use the stoichiometric calculation. The question is, dinitrogen and hydrogen react with each other to produce ammonia according to the given equation. Now, the equation is N2 plus 3H2 gives us 2NH3. So while I am reading this question, you must also analyze that. Okay, what is, at least you must get at what is this question asking. First of all, this should be clear to you. Then this is your equation. Now it is being asked that what is the mass of ammonia produced if we take 2000 dinitrogen and react it with 1000 gram of nitrogen. Okay, we take 2000 grams of dinitrogen and react it with 1000 grams of nitrogen. The second question is, will any two reactants remain unreacted? If yes, then what would be its mass? So let's see how we can solve it. So first of all, you have to look at this reaction and determine that what is the limiting reagent and what is the mass of the product and reactants that are formed. We will do it step by step. So in this method, I will try to redistribute the marks also, because there are multiple parts of it. The first part is of 1 marks. The second part is also of 1 marks. But in this second question, there are again 2 parts. And each of them will have half of marks contribution. So already I am getting some answers. Let's see if they are true or not. First of all, what we will do is to calculate the mass of ammonia which will be produced in 2000 grams reacting with 1000 grams dihydrogen. Yes, what is your doubt? This is our balanced chemical equation, N2 plus 3H2 giving us 2 moles of ammonia. Then what is the molar mass of nitrogen? It is 28 gram per mole. Hydrogen's molar mass is 2 gram per mole and ammonia's molar mass is 17 gram per mole. So I am not again calculating the molar masses here, since you already know that how do we calculate it. So it's very simple, okay. So just take the atomic weight of nitrogen. You have to remember this masses. Okay, so this is given in your NCERT book as well, in the periodic table chapter. Not of all elements, I would say, but up till the sodium line. So if you look at the periodic table, we have a line where we have the sodium. So up till that point, at least you should remember, like of nitrogen, carbon, oxygen, hydrogen. So the small elements atomic mass should be remembered. So nitrogen has an atomic mass of 14 and hydrogen has an atomic mass of 3. But there are 3 hydrogens, so we will multiply the 1 by 3. Do this simple sum, you will get it 17 gram per mole. Okay. So in this chapter, I would say that up till sodium it is okay. But if you are able to remember zinc, up till zinc, then it is well and good. It will help you in your upcoming chapters also. So did you get the point how I am calculating the molar mass? So you must remember the atomic mass. In most of the cases, it is double the value of the atomic number, but it will not work well each time. Like in the case of chlorine, it is 35.5. Okay. So now it is clear how I am calculating this molar mass. So if you know the molar mass and if you know the given mass, we can calculate the number of moles. So it would be 2000 by 28. Again, the simple formula, I use it every time. Okay, so very important. So 2000 gram by 28 gram will give you 71.43 moles. So this is your number of moles for the case of nitrogen. What about hydrogen? Again, it will be 1000 by 2. Why I am taking it 2? Because there are 2 hydrogens. So 2 multiplied by 1 will give you 1, which will be equals to 500 mole. Now we know the moles. Now here comes the part of unitary method. It is very clear from the equation that 1 mole of nitrogen is reacting with 3 moles of hydrogen to give 2 moles of ammonia. Right? So if 1 mole of nitrogen is reacting with 3 moles of hydrogen, then 71.43 mole will react with 71.43 into 3 moles of hydrogen. Again, that same analogy of the chocolates. Here I have used that thing. So if again I am repeating this thing, that if 1 mole is reacting of nitrogen is reacting with 3 moles of hydrogen, then 71.43 moles of nitrogen will react with 71.43 into 3 moles of hydrogen. So that is 214.29. So we require this much hydrogen to completely react with the given nitrogen. Is this thing clear? Have you got my point? Yes. So N will be the limiting reagent. Very good. Let's see if it is there or not. So we can easily say it from here. that we require 214.29 moles of hydrogen. But we have 500 moles of hydrogen. Okay, we have 500 moles of hydrogen. So how are we taking it 6? Abhi, can you explain this thing to me? So we have to take this thing. Okay, so molar mass is related to the moles. You do not consider this stoichiometric coefficient. Okay, you do not consider this because molar mass is related to the molecule, not to the stoichiometric coefficient. If you take it 6, then the molar mass of hydrogen will vary each time for different equation, and it is very you would say unpredictable, and it will be of no use then. So till now we know that we need 214.29 moles of hydrogen, but we have 500 moles. So we can say that nitrogen is the limiting reagent. Which is the limiting reagent? Nitrogen is the limiting reagent, and hydrogen is present in excess. Then if I ask you what is the moles of ammonia produced, what you will say? So if 1 mole of nitrogen is producing 2 moles of ammonia, then 71.43 moles of nitrogen will produce 71.43 into 2 moles of nitrogen. So that will be equals to 142.86 moles of ammonia. Sorry, this will be ammonia, not nitrogen, ammonia. Is it clear? Again, here I am used this is stoichiometric coefficient to calculate this. So now we have the moles of ammonia. Can we calculate the mass? So the formula for the mass calculation from moles is molar mass into number of moles. So I have just cross multiplied our equation. So ammonia's molecular formula is NH3. How I have calculated the number of moles of ammonia? Okay, very good. So we know that 1 mole of nitrogen is producing 2 moles of ammonia from this equation. That means 2 moles of nitrogen will produce 4 moles of ammonia. Simple. Multiply 2 and 2, you will get 4. But what about 71.43 mole? Then for 71.43 mole, you have to multiply with 2 to get the number of moles that ammonia will formed. Okay. Now, if we know the number of moles, we can calculate the mass by simply multiplying 142.86 with 17. So 17 is the molar mass. We know the formula. Number of moles equal to given mass by molar mass. So given mass equal to molar mass into number of moles. Here we can clearly say that okay, this is the given mass. Is limiting reagent equal to number of moles divided by stoichiometric coefficient. So I didn't get your question. There is no such formula. You just look at the calculations, right? So you can see it here. Again, I am repeating it. That we have this much moles of nitrogen and we have this much moles of hydrogen. Now from this stoichiometric equation, we can say that our 71.43 mole will require 214.29 mole. But we have extra amount of hydrogen moles that is present. Since hydrogen is present in extra amount and nitrogen is present in a lesser amount, therefore it will be the one which will be limiting reagent. As simple as that. So limiting means present in less amount, whose scarcity is there, not the one which is present in excess. Got it? So we have already answered the first part of the say your second question, and the first question is wholly answered, which is 242.62 grams. The second part is asking that will any of two reactants remains unreacted? Yes, it will be remained, and that will be hydrogen because it is present in excess. Then we have to calculate the mass of this unreacted hydrogen. How we'll do it? Let's see. So to calculate that, we must write the first answer. which is whose mass is remain unreacted. So it will be N2. Okay, so this will be N2. Sorry for this. This will be N2 here. Nitrogen is the limiting reagent. Okay, so there is a correction here. So if you write this, you get your half marks, because this 1 marks question, you will get half marks here. Then what is the moles of hydrogen that is used? What was the moles of hydrogen that was used? We have calculated this thing. It was 214.29. Okay, we have seen this. Since we have 71.43 moles of nitrogen, then it will require 214.29 moles of hydrogen. Then since we have 500 moles, and if we subtract the reacting hydrogen from it, you will get the unreacted hydrogen, which is 285.71 moles. So this will be your remaining half marks if you calculate the mass, which is the double of this number of moles. Again, this will be nitrogen. Do not get confused from here. So it will be nitrogen. Anyone has any issue in this question? So second part may be somewhat difficult for you. It has somewhat complication. I have just calculated the required number of hydrogen for the given nitrogen and subtracted it from the amount of hydrogen that we have. Again, I am repeating it. The first thing is we have already calculated the number of moles for hydrogen and nitrogen, and we have seen that we have 71.43 moles of nitrogen. That means how many moles of hydrogen was required? 1 is equals to 3. So 71.43 is equals to 214.29. So we require this much moles of hydrogen to completely consume our nitrogen. Then since we have excess hydrogen, which is 500, if we subtract it from the consumed ones, then we will get the unreacted hydrogen part. Got it? Sir, may you say or write all formulas? So if possible, I will give you this thing also, the formula thing. Now is it clear? Okay, so if you do it, you will get your half marks. Remember, N2 is the limiting reagent. So this one is written wrongly here. Sorry for that. Moving on to the next question. Again, it is a very short answer type question. You have to calculate the number of atoms in 52 moles of helium and 52 grams of helium. It's a very easy question. I would suggest you to start writing the correct answer in the chat section. You have to just calculate the number of atoms in 52 moles of helium and 52 grams of helium. How will do it? How will calculate the number of atoms? So first of all, I will calculate the number of atoms in 52 moles of helium. If anyone is facing difficulty in solving these questions, so no issues in that. Just try to do it by yourself. Once I complete this lecture, you can go and check my lecture in the YouTube on the website also. I would suggest you to go and check it in the website, as there is DPP and related to it given there. Okay. So here I would so go and please check the website for the same lecture. Here you have to calculate the number of atoms in 52 moles of helium. So it's very simple. How we'll do it? We know that 1 mole of any substance will contain 6.022 into 10 to the power 23 atoms. So in this case we are dealing with atoms, so I have written it atom. But how many moles we have? Do we have 1 mole? No, we have 52 mole. We will simply multiply 52 by 6.022 into 10 to the power 23. So if you do that, you will get this thing. Therefore, the complete answer would be 313.144 into 10 to the power 23. If I write it more scientifically, then what I will write? It will be 3.13 into 10 to the power 25. Okay, so is this clear to you? So this was also of 1 mark. So you have to do the whole calculation to get this marks. Anyone has any problem with this question? It's very simple again. So once you get this type of mole calculation and move on to the stoichiometric calculation and calculate the limiting reagent thing, then you will easily able to solve the question. So we have 52 grams of helium and you have to calculate the number of atoms. How we will do it? To get this, you need the number of moles. Okay, you need the number of moles. So I'm getting answer 52. Let's see if it is correct or not. How do we know the number of moles? So for that, we need the molar mass. Molar mass of helium is 4. 4 gram per mole is the molar mass. Therefore, what will be the number of moles? It will be given mass by molar mass, that is equals to 13 moles. So 52 gram was the given mass and molar mass is 4 gram. So we have 13 moles of helium. Now since we have the number of moles, we can easily use it to calculate the number of atoms, which is 13 into Na, 6.022 into 10 to the power 23. So why I am converting it to 10 to the power 25? So it is a scientific way to write anything. Okay, so suppose you get your answer as 31.2 into 10 to the power 6. So what we do is we keep the decimal just after the first digit. So the first digit is 6. How you will keep it here? You will multiply it with say 10 and divide the same by 10. Now if you do this calculation, you will get 3.12 and 10 to the power 6 multiplied by 10, 10 to the power 7. So it is a more scientific way of writing your answer. So sadly that thing is not in a syllabus. For that you can go and watch the physics lecture. I think the significant figure is being discussed in detail also there. Now coming back to our questions, we know the number of moles and we know that in 1 mole we have 6.022 into 10 to the power 23 atoms. Then in 13 moles we will have 13 into 6.022 into 10 to the power 23 atoms. If you do this calculation, you will get it as 7.83 into 10 to the power 24. Okay, so there is a small change in your answer. It will be not 23, it will be 24. Because we are moving the decimal from right to left by 1 decimal. If you are finding difficulty in moving this decimal, there is a very short trick for it. Just remember this trick. If you are moving the decimal to the left, then increase the power. First thing, moving to the left increases the power, moving to the right decreases the power. Now how much decimal you increase, that will be the count of the increase. So suppose here we are moving to the left, we will increase the power. We are moving by 1 digit, so we will increase this 23 by 1, that is 24. If you are having any confusion in this writing way, then you can easily follow this trick. Moving left, increase the value, moving right, decrease the value. If you move to the left by 1 digit, increase the power by 1 digit. If you move to the left by 2 digits, increase the power by 2 digits. So this is also of 1 marks. So the first and second part are being solved. So anyone has any issue in this question? Now we will move to the next type of question, which is short answer type, and it comprises of 3 marks. Now this question has sub part and each sub part has 1 mark each. So that will go and sum it to total of 3. I will request you to go and write the correct answer in the chat section. What will be the answer for each of this? The question is saying that we are taking 3 moles of ethane. Then what will be the number of moles of carbon in this 3 moles of ethane? First question. number of moles of hydrogen in 3 moles of ethane. And third one, what is the number of molecules of ethane? Let's see how we can do it. Okay, so I am unaware about it, Pratik. I will talk to the team that why it is happening. So the question is, no problem. You can now write if it is there. So you have to calculate the number of moles of carbon, calculate the number of moles of hydrogen atoms, and number of ethane in 3 moles of ethane. Our first question says that number of moles of carbon. Now, what will be the number of moles of carbon in 1 mole of ethane? It will be 6, because in 1 mole there are 2 carbons. Then in 3 moles there will be 3 into 2, that is 6 moles. Got it? Again I am repeating it. We know that in 1 mole of ethane we will have 2 moles of carbon atoms and 6 moles of hydrogen atoms. Right? Because since there are 1 mole of ethane and in each molecule of ethane we have 2 carbon. So therefore in 1 mole we have 2 moles of carbon. Is there any issue in this point that 1 mole has 2 moles of carbon? 1 mole of this ethane has 2 moles of carbon. You don't need mass. Is it clear that 1 mole will have 2 moles of carbon? Again I am repeating it. Suppose you have 6 molecules of ethane. Okay, so these are the molecules of ethane. Suppose you have 6 molecules of ethane, or I would say suppose you have 3 molecules of ethane. Then what will be the number of carbon in these 3 molecules? It will be 2 plus 2 plus 2. That will be 6 atoms of carbon. Okay. So for each ethane you are getting a contribution of 2 carbon. In this question you have 3 moles of ethane. So similar thing can be applied to here. That means 3 multiplied by 2 will give you 6 moles. Clear? You got my point now? Yes, I would say that just try to practice this writing in standard form. It will give you a more scientific way of representing your things. Because in your JEE questions, you will see that your answer may be given in your different forms. So if you are able to convert it very quickly, then it will be helpful there also. Now coming back to the question, 1 mole of ethane will have 2 moles of carbon. Therefore, 3 moles of ethane will have 6 moles of carbon. Similar to that, what will be the moles of hydrogen atom? So 1 mole has 6 moles of hydrogen. Therefore, 3 moles will have 18 moles. 3 multiplied by 6. The last question is the most easiest one. That what is the molecules of ethane? Again, the molecule thing is same. 6.022 multiplied by the 23, 10 to the power 23 into 3. That will give you 1.806 into 10 to the power 23 molecules. Okay. So all of these questions were of 1 mark. So sorry, I'm not getting a question here. What I was trying to ask. It is written NH3. Yes, sorry, what is the doubt? Okay, NH3 what? No, ethane's formula is C2H6. Methane formula is CH4. Ethane formula is C2H6. Okay. So these are the 3 parts of the question. Now, this is a long answer type question. Here, this question may look difficult to you from first point of view, but believe me, it's a very easy question to solve. But what the point is that you have to move to and fro with the unitary method. Okay, there will be a lot of use in this unitary method thing. Yes, you can write 3 into NA, but maybe in the exam, your teacher won't accept this way of writing. So I will suggest you to just multiply this thing. So what you have to do is to prove a law of chemical combination. So this is from the NCERT section 1.5. How we'll do this question? So for that, you must know first of all what is your law of multiple proportion. It says that if two compounds can be formed, two or more compounds can be formed from the same constituent elements, then they do so in a fixed mass of the other, and there is a simple ratio to it. Now what is the meaning of this? We will try to again understand. So I've already explained this. So when you will see the example, you would get a clear idea. Okay, no issue in that. But you must know the unitary method here. It's very important to solve this. Maybe you will find difficulty if you don't know it. And we are also lacking of time. There is a next class ahead of me. So I have to do it quickly. So if there is a problem in this, you can ask it in the later on classes. Okay. So let us start the solution. So what you have to do here is to form different compounds. These are the 4 compounds AB, AB2, A2B, A2B3. Okay, so these are the 4 compounds, and the mass of each is given. The first is having a 2 gram mass, A is having a 2 gram mass, and B is having a 5 gram mass. Means A molecule has a mass of 2 gram, B molecule has a mass of 5 grams. Now, if you have to form this AB molecule, then what is the weight of B that is required by A if the weight of A is 1? So first of all, you can look at here and say that if I want to form AB, then 2 gram will require 5 gram. 2 gram of A will require 5 gram because 1A and 1B will come together. So AB is just a representation. If you have any issue, I will re-explain it. So I'm quickly going through it because we have a class ahead of it. Sorry if I can't explain it very clearly in this class. I will put this question once again there. Okay, so this is just a molecule AB, AB2, A2B, and these are being formed from the atoms A and B. Again, coming on to the question, if 2 gram of A is reacting with 5 gram of B to form AB, then 1 gram of A will react with 5 by 2 gram, that is 2.5. Similarly, for AB2, you will get 5. For A2B, 1.25. For A2B3, 3.75. Then, what is the ratio of A and B? It is being given here. So, the law of multiple proportion says that, yes, I will explain this, re-explain this for sure. So, the law of multiple proportional says that if A and B can form 2 compounds, then the ratio of B in each of these compound will be a simple whole ratio number. How? Just try to find the common ratio between each of this mass. So if you write this table, I'm sure you will get 3 marks in this. But still just try to understand this, and if you want to understand it more better way, then please read the laws of multiproportion, then come to the next class. Okay. So how we'll solve it? So this was the ratio that we will get if we take the ratios of B in all the compounds. And since all these ratios are simple whole number ratio, therefore it is following the law of multiple proportion. Okay, so this will comprise of the remaining 2 marks. Okay, thank you. This was all for today's class. In few minutes, our next maths faculty will join you. Please be there. So I will recommend some good books in the next class. Okay.